channel. In this video we will talk about subsets and power sets. If every element of set A is also an element of set B, then set A is a subset of set B. We use this symbol to denote a subset, which means is contained in. So sometimes we will say A is contained in B. Sometimes people say A is a subset of B. To denote A is a subset of B, so we use this symbol here. Now we can also show subsets using a Venn diagram. In a Venn diagram we have the universal set, set B. Since set A is contained in set B, we will have set B drawn in set A drawn inside set B. So we will have this Venn diagram that represents set A is contained in set B. If A is not a subset of set B, then we will say A is not contained in B. So we use this symbol to denote that. Let's look at this example. C is equals to the set of elements 1, 2, and 4. D is equals to the set of elements 1, 2, 3. Here we can see that elements of C are not exactly the same as the element of set D. Well, you have 1 and 2 in set D, so is 1 and 2 in set C. However, for set C to be contained in set D, all elements of set C must be elements of set D. So it doesn't happen. Therefore, set C is not a subset of set D. Set C has 1 and 2 also here, but set C has 4. You cannot find 4 here. We can also say set D is not a subset of set C. We can see that we have 1 and 2 in set D, also 1 and 2 in set C. However, we have 3 in set D, but we don't have 3 in set C. Therefore, we can also say set D is not a subset of set C. Now, is set C equals to set D? Well, the answer is no. In order for two sets to be equal, they must have exactly the same elements. Every set is a subset of itself. For instance, set A is a subset of set A, or set B is a subset of set B. Importantly, we should also note that empty set or null set is a subset of every set. Let's take this example. List all subsets of set A. Subsets means it must be contained in. So we have set A here with the elements A, B, C. So all the subsets of set A now will be, well, by definition, null set is a subset of every set, so definitely null set is a subset of A. Element A is contained in set A, so set A here having elements A, set having element B, set having element C, set having element AB, set having element AC, and set A itself, which contains the element A, B, and C. So these are all subsets of set A. Let's look at another example. We have set B. Now list all the elements of set B. Set B is equals to the set letters in the word moon. Now, moon has two letter holes, but when we list the elements of set B, we only need to list letter O once. So we will have all subsets of set B will be null set by definition. Null set is a subset of every set. Set having letter M, set having letter O, the set having letter N, the set having letter M and O, the set having letter O and N, the set having letter M and N, and the set itself, which is set B, having letter M, O and N. The collection of all subsets of set A, okay, is called the power set of A. So let's look at set A here. Set A is equals to the set having the elements A, B and C, but all the subsets of set A are listed here, that is the null set and the rest. Now when we have all of those subsets, okay, included in the set, then it becomes power set. Okay, it is denoted by P of A. So when we put all these subsets in a set, that becomes the power set of A. Or for this one too, if you put all the elements, subsets, okay, I should say, in the set, then it becomes the power set of the set, and here is B. So let's look at how we can write power set of A. So we will have power set of A, okay, null set, and all the rest, all the subsets of set A are listed in this set. You see, so we should have this open curly braces, list all the subsets inside, and then the close curly braces. Then we will say that this is the power set of set A. Thank you all for watching. See you in the next video. Bye for now.